The SR745 Transformer Management Relay is a microprocessor-based relay designed for the protection and management of 2- and 3-winding transformers. It is equipped with 8 output relays that can be user-configured for trips, alarms, and control functions, as well as dedicated self-test alarm and high-speed solid-state trip contacts. 16 logic inputs may be configured for different functions, such as remote opening and closing of the breaker, reset, or alarm with a programmable name. The main protection element of the SR745 is the phase differential. The 745 uses a 2-slope percent differential scheme, allowing for sensitive differential protection in zone faults while blocking the operation of the differential element for out-of-zone faults. Transformer protection, fault diagnostics, power metering, and RTU functions are integrated into one economical draw-out package. LED indicators for the 745 status, system status, and active conditions, in addition to a 40-character message display and keypad, allow control, programming, and status monitoring without the need for a computer. However, the conveniently located front RS-232 port allows easy connection to a computer for programming and monitoring. The relay's draw-out handle has provision for a wire lead seal to detect unauthorized removal. The relay is packaged in the standard Multilin SR series configuration of a draw-out unit and a companion fixed case. The case provides both mechanical protection and is the termination for all connections to external equipment. Current transformer connections within the case are fitted with automatic CT shorting mechanisms. The unit is held in the case by pins on the locking handle, which cannot be fully lowered to the locked position until all electrical connections are fully mated. Any SR745 can be installed in any SR745 case. An index pin keying mechanism prevents other models of SR relays from being inserted into the SR745 case. All messages are displayed on a 40-character liquid crystal display to make them visible under poor lighting conditions. While the keypad and display are not being used, the display will default to user-defined status messages. Any trip or alarm will automatically override the default messages and appear on the display. There are 2 different displays available for the SR745 relay. These are the Enhanced and Basic. New production units will be enhanced, while older relays already installed may have the Basic display. The main difference between the Basic and Enhanced display is a larger LCD display and the keypad interface. The Basic display uses separate setpoint and actual keys to enter the main headings. The actual key is used to navigate through the headers of pages of measured parameters, while the setpoint key is used to navigate through the headers of pages of programmable parameters. The actual key will enter a different actual value heading each time it is pressed. Once you have entered the actual value heading you want to view, the message up and down keys may be used to navigate through the subgroups. The functionality of the remaining keys remains the same as the enhanced display. There are 3 groups of LED indicators on the faceplate that indicate the status of the relay, system, and active conditions. The meaning of these indicators is as follows. First, let's look at the relay status LED indicators. The in-service LED indicates that control power is applied and all monitored input, output, and internal systems are OK, and the relay has been programmed and is in protection mode, not simulation mode. The self-test error LED indicates that the self-test relay has operated or energized. There are 2 sources of self-test errors, the first being the detection of an internal failure of the relay. The second cause of the self-test error is misapplied settings. If conflicting flex logic or transformer settings have been programmed, the relay will issue a self-test error alerting you to the conflict. A complete list of the self-test errors and their causes can be found in the relay instruction manual. The test mode LED will illuminate when the relay has been forced into the simulation mode, or if any of the output contacts have been forced using the testing functions of the relay. Any operation of the relay will be based on the simulated values or commands issued to force the contacts, not on measured system information. The differential blocked LED indicates that the differential element has been enabled, but is being blocked by one of the harmonic restraint functions of the relay. The local LED is on when the reset button on the front of the relay has been enabled. This allows latched elements to be reset using the front panel of the relay. The message LED will indicate when there is a target message, such as a trip or alarm, present in the relay. If there is more than one message, using the Message Down button will scroll through the messages. Now we'll look at the System Status LED indicators. The Transformer De-Energized LED indicates the Energization Inhibit feature of the relay has detected that the transformer is de-energized. The Transformer Overload will turn on when the Transformer Overload element has operated. The Load Limit Reduced LED is on when the Adaptive Harmonic Factor Correction element of the relay is detecting enough harmonic content to reduce the load rating of the transformer. The Setpoint Group 1 through Setpoint Group 4 LEDs will indicate which of the 4 sets of protection elements is being used to protect the system. If an LED is solid, this means that the indicated group is protecting. A Setpoint Group LED will flash when that setpoint group is being edited, but only if another setpoint group is being used to protect the system. For example, if Setpoint Group 1 is the active or protecting setpoint group, but the setpoints under Setpoints Group 4 are being edited, the Setpoint Group 1 LED will be solid and the Setpoint Group 4 LED will be flashing. Finally, let's look at the Condition LED indicators. The Trip LED indicates that an output contact programmed to trip has operated. The Alarm LED indicates that an output contact programmed to alarm has operated. The Pickup LED indicates that a timed element, such as the timed overcurrent, has picked up and is timing out towards a trip. The Phase A, Phase B, Phase C, and Ground LEDs will indicate which of the phases has operated the trip, alarm, or pickup LEDs. For instance, if there's been a trip due to Phase B overcurrent, the Trip and Phase B LEDs will be illuminated. The relay's messages are organized into pages under the main headings of Set Points, Actual Values, and Active Targets. The menu key is used to navigate through the main headings. Each page is broken down further into logical subgroups of messages. The message keys may be used to navigate through the subgroups. For example, when the menu key has been used to select the Actual Value main page, pressing the Message Right key will move you into the A1 status menu. The Message Up and Message Down buttons can then be used to view the headers for the other Actual Value submenus, such as A2 Metering and A3 Event Recorder. To view the specific information in a subheading, use the Message Right key. For example, when in the A1 status subheading, press Message Right to see the heading for date and time. The Message Up and Down keys can again be used to navigate the headings under the A1 status subheading. The Enter key has a dual purpose. It is used to either enter the subgroups or store altered setpoint values. The Escape key is also dual purpose. It may be used to exit the subgroups, or it can be pressed to return an altered setpoint to its original value before it's been stored. The Value Up and Down key is used to scroll through variables in the setpoint programming mode. It will increment and decrement numerical setpoint values. Alternatively, these values may be entered with the numeric keypad. The Help key may be pressed at any time for context-sensitive help messages. The Relay Front RS-232 port. This port is intended for connection to a portable PC. Setpoint files may be created at any location and downloaded through this port using the EnerVista setup program. Local interrogation of setpoints and actual values is also possible. New firmware may be downloaded to the relay flash memory through this port. Upgrading of the relay firmware does not require a hardware EPROM change. Relay installation. The relay case can be installed in the panel of a standard 19-inch rack, either alone or adjacent to another SR series unit. Make sure that the front door of the relay is able to swing open without interfering with adjacent equipment. Normally, the relay is shipped in its case from the factory. The relay should be removed from its case before mounting the case in the supporting panel. To remove the unit from the case, first turn off control power before drawing out or reinserting the unit to avoid maloperation. To remove the unit from the case, open the cover by grasping the center of the right side. Press upward on the latch and then pull the front door, which will rotate about the hinges on the left. Release the locking latch located below the locking handle by pressing upward on the latch with the tip of a screwdriver. While holding the latch raised, grasp the locking handle in the center and pull firmly, rotating the handle up from the bottom of the unit until movement ceases. Rotate the handle to the stop position. Once the handle is released from the locking mechanism, the unit can freely slide out of the case when pulled by the handle. It may sometimes be necessary to adjust the handle position slightly to free the unit. Mounting instructions. Review the dimensions and location of the relay wiring before selecting a location within the panel that is appropriate for the relay. Cut the hole in the panel to the dimensions shown in the drawings. After the mounting hole in the panel has been prepared, slide the relay case into the panel from the front. Apply firm pressure on the front to ensure the front bezel fits snugly against the front of the panel. Bend out the pair of retaining tabs to a horizontal position from each side of the case. The case is now securely mounted and ready for panel wiring. If additional support is desired, the optional SR mounting kit may be ordered. Inserting the unit into the case. If an attempt is made to install a unit into a non-matching case, the mechanical key will prevent full insertion of the unit. Do not apply strong force in the following step, or damage may result. Raise the locking handle to the highest position. Hold the unit in front of the case and align the rolling guide pins near the hinges of the locking handle with the guide slots on either side of the case. Slide the unit into the case until the guide pins on the unit have engaged the guide slots on either side of the case. Grasp the locking handle in the center and press down firmly, rotating the handle from the raised position towards the bottom of the unit. When the unit is fully inserted, the latch will be heard to click, locking the handle in the final position. There are a total of 16 digital inputs that are designed for dry or wet contact connection vices. One of the digital inputs, the setpoint access input, has its own common, while the rest of the inputs share commons. The setpoint access switch allows the front keypad to be used to program the relay. This can be wired as a dry contact connection only. When wiring the digital inputs to the relay, it is important that terminal D11 is used as the common for all dry contact connections. This terminal is connected to an internal 32-volt supply which is used to power the digital input circuitry. Connecting an external source of power or using a wet contact connection with this terminal will damage the relay. When using a wet contact connection, use terminal D12 as the common. The negative side of the external supply must be connected to this terminal. Improper orientation of the wiring can result in damage to the relay. The control power supplied to the relay must match the installed switching power supply. If the applied voltage does not match, damage to the unit may occur. The order code on the terminal label on the side of the drawout unit specifies the nominal control voltage as one of the following. For low voltage connection, the label will read low 20 to 60 VDC, 20 to 48 VAC. For high voltage connection, the label will read high 88 to 300 VDC, 70 to 265 VAC. Extensive filtering and transient protection are built into the relay to ensure proper operation in harsh industrial environments. Transient energy must be conducted back to the source through the filter ground terminal. A separate safety ground terminal is provided for high-pot testing. All grounds must be hooked up for normal operation regardless of control power supply type. Ground current input connection options. There are two independent ground CT connections on this relay. Terminals G10 and H10 are the G12 ground connection. Terminals F12 and E12 are the G23 ground connection. The G12 ground connection will be used for windings 1 and 2, while the G23 connection will be used for winding 2 and winding 3. The type of transformer that the 745 is protecting will determine which ground connection is being used. For example, a wide delta transformer only has a neutral conductor on the primary winding, or winding 1 of the transformer. The G12 ground connection will be used for this transformer type. A YY delta transformer has neutral conductors on winding 1 and winding 2. For this transformer, the G12 ground connection will be used for the winding 1 ground, while the G23 connection will be used for the winding 2 connection. The 745 instruction manual contains an auto configuration section dedicated to explaining the phase relations and ground connections for different types of transformers. This is a useful tool for determining which ground connection should be used for your specific application. For the example of a delta Y30 transformer, you can see that the Y winding will lag the delta winding by 330 degrees, and that ground on the Y side of the transformer can be connected using the ground 1-2 terminals. There is no ground connection indicated for the delta winding, as delta systems do not contain a neutral conductor. The secondary CT value must be specified as 1 amp or 5 amp when the relay is ordered. An order code containing a G5 must have a ground CT with a 5 amp secondary installed. A G1 requires a 1 amp secondary CT. Ground CTs can be specified separately for each winding. For instance, a G51 in the order code indicates a 5 amp secondary for the ground 1-2 connection and a 1 amp secondary for the ground 2-3 connection. There are 3 methods for connecting the ground inputs of the relay to the system. The first is a dedicated ground CT connected to the neutral leg of the Y winding. The second is a residual ground connection. This reduces the cost of implementing ground protection, but it increases the error in the system due to the accuracy limitations of the 3-phase CTs. Pickup levels will need to be set higher with this CT configuration. The third method is to use a zero-sequence CT. This provides the most accurate ground protection and allows more sensitive pickup levels for ground overcurrent protection. A CT must be chosen that allows all 3 conductors to pass through the window. The exact placement of a zero-sequence CT so that only ground fault current will be detected is shown here. If the core balance CT is placed over shielded cable, capacitive coupling of noise into the cable shield may be detected as ground current unless the shield wire is also passed back through the CT window. Passing the cable back through at 180 degrees will cancel out any noise seen in the cable shield. Twisted pair cabling on the zero-sequence CT is recommended. There is a single voltage input provided with the SR745 relay. This input is used for monitoring the voltage and frequency in the system. If enabled, this input will be used for all power calculations, as well as frequency and overexcitation protection elements. Voltage metering can also be programmed to detect the energization of the transformer. There is a maximum VT ratio of 5,000 to 1 allowed, and the nominal secondary voltage must fall between 60 and 120 volts phase to phase. This will allow proper metering of system voltages, as well as protect the relay from damage due to high voltages. At this time, it is appropriate to review the terms failsafe and non-failsafe. GE Multilin defines a failsafe relay as a relay that is normally energized and de-energized when called upon to operate. It will also de-energize when the relay control power is lost. Within the relay, there is only one output contact that will always operate as failsafe. This is the self-test relay. It has a Form C contact output configuration that will energize when control power is applied to the relay and will de-energize if a relay hardware or programming error is detected. The other 7 relays are defaulted to non-failsafe. They will normally be de-energized and will energize when called upon to operate. If failsafe operation is required from one of the programmable outputs, their non-operated state can be programmed to energize using flex logic converters. This option will be discussed later in the flex logic section. Shorting bars in the drawout case ensure that no trip or alarm occurs when the relay is drawn out. However, any output relays that have been programmed as failsafe, including the self-test relay, will de-energize. Any device connected to the failsafe relay terminals will detect this change in state. The SR745 relay does not have a dedicated trip contact. Any of the 8 assignable output contacts can be programmed as trip, alarm, or control. This allows a number of breakers to be controlled using one relay. Operation of the output contacts can be assigned to individual protection elements, logic or virtual inputs, contact or virtual outputs, and internal timers. This allows great flexibility when programming output contacts to meet your specific system and control requirements. R2 to R5 are normally open Form A contacts. Although all 8 contacts can be programmed to operate as a trip, these 4 contacts have been designed with higher current and maximum load ratings and are designed specifically for the energization of trip coils. It is recommended that these contacts be used for any tripping operation. The remaining 3 programmable relays are Form C contacts, consisting of 3 terminals per contact. They are the normally open, normally closed, and common terminals. Any contacts not assigned to a trip function can be programmed and wired as an alarm or control output. This allows signals to be sent to enunciator panels, SCADA or PLC devices, as well as upstream protection devices. The relay is also equipped with a high-speed solid-state trip output. This output is designed for applications where it is required to key a communication channel. It is not intended to operate the trip coil and cannot withstand the current required in the tripping circuitry. The Failsafe self-test relay will operate, in other words, de-energize, if the relay detects an internal fault or power to the relay has been removed. It will also operate if the relay determines that any of the programmed settings are in conflict with each other. A self-test alarm will be present on the display of the relay whenever the self-test relay operates. The self-test output may be monitored with an annunciator, PLC, or DCS. Another application is to wire the self-test relay normally closed contact in parallel with the trip relay auxiliary on a breaker. This will provide fail-safe operation of the system. The breaker will be tripped offline in the event that the relay loses power or has an internal failure and is unable to provide protection. The relay is equipped with 3 independent communications ports. The front RS-232 port is designed for direct connection to a PC. There are also 2 communications ports located on the rear terminals of the relay. COM1 can be configured as an RS-485 or RS-422 communication port. COM2 is a dedicated RS-485 port. The front RS-232 port requires a straight-through RS-232 cable to connect it to a PC. It is intended for accessing settings, event recorder, and oscillography files, as well as upgrading firmware to the relay. The baud rate and parity are programmable. The rear communication ports are independent RS-485 ports, with COM1 having the ability to be configured for RS-422 hardware. Both ports can be accessed at the same time and are intended to be connected to a Modbus communication network. A maximum of 32 devices can be connected to a single daisy chain. Baud rates and parity can be set independently for each port. To reduce communication errors caused by noise, shielded twisted pair cable is recommended. The cable should be grounded at only one end, either at the relay or the master device. Terminating resistors and capacitors are also recommended to reduce interference. The relay is equipped with a single RTD input, able to connect to different types of RTDs. The RTD input is intended for measuring the ambient temperature of the transformer. Monthly averages are calculated and stored in the relay. 2- and 3-wire connections are available. However, 3-wire connections are recommended as it allows compensation for the resistance of the RTD leads. This provides greater accuracy in the temperature measurements. To allow accurate time stamping of events and waveform captures, the relay can be connected to an iRig-b signal. Multiple relays can be connected to the iRig-b generator using coaxial cable. The number of relays that can be connected to the generator will depend on the load rating of the generator.